A look through this prism may require a controller and quick, fine motor reflexes. The notion of zombies staring at the television playing video games may be one that receives a pretty low score, according to recent research. According to scientists at Duke University, gamers are learning to perceive the world more carefully and also exercising their mind during play. Here to help us move beyond level 1 is Dr. Greg Applebaum. He's an assistant professor of psychiatry in the Duke School of Medicine. Welcome, Dr. Applebaum.
Thank you.
So, video games might be good for us. You do realize that this study might make some parents unhappy with you. You're taking some pretty powerful arrows out of their quivers when they try to get their kids outside to play for a bit.
I'm not sure that their critiques aren't right also, but we are finding some positive effects on visual cognition in our study.
And what would those be, actually? What kind of advantages are we seeing? Are these in the perceptual realm, the memory problem solving?
Interestingly enough, we're actually kind of looking at both of these. We're interested in both perception and memory. So we were testing the hypothesis that video game players may see the world better and may retain information that they see from the world in short-lived visual memory buffers better. What we found in the study was that in fact, they do see the world better when you present a very briefly displayed visual scene. They can actually extract more information from that scene, but they don't actually retain that information any longer. They just see it better right up front, and then there's more information in their memory buffers, but it doesn't stick around longer.
Are they seeing things better in a 2D schema, in a more naturalistic setting? What kind of environments are they able to pick out these stimuli better?
These are fairly simplistic psychology experiments, definitely 2D. They're actually arrays of letters. So, much of what you think of in these video games is three-dimensional, virtual-ish kind of reality. And what we were actually testing was very simple two-dimensional vision.
And so when you're looking at that TV screen or the computer monitor and you see these virtual realities displayed before you, it's training the mind to pick out dangers or clues or treasures or whatever they are. And you find that that's translating or being more generalizable into other settings?
More or less. So we want to be careful not to establish causality here because our study is just looking at people who are high video gamers versus low video gamers, people who play a lot versus people who don't play a lot. So whether the gaming is causing that is yet another kind of deeper question. But when you take people who are either active video game players who play a lot or people who are not video game players and look at their abilities, it turns out that the video game players have greater abilities.
How did you test this?
Actually, this is part of a larger study going on at Duke in the visual cognition lab of Steve Mitroff, and that gives us access to a whole lot of participants. So we bring lots and lots of people in, and we measure them on a whole lot of attributes. We're interested in who they are, what their pastimes are, what type of personality traits they have, things of that nature. And then we're also interested in their visual cognition, their visual abilities. So we brought people in, and amongst this larger battery, we asked them about their video gaming habits. So that gave us the ability to segregate between people who play lots and lots of video games versus people who don't play. And then we also measured visual cognition using a task which is called an iconic memory task. And what this does is it's a briefly presented display of letters. There's 8 letters that flash up very, very quickly. And after the display disappears, a cue pops up. And the cue points to one of the locations and asks the person to report what letter was at that location. And the manipulation that's going on is the delay between the offset of the array of letters and the onset of the cue. And if the cue comes very, very quickly, then the people don't have to retain the information very long and they perform very well. And the longer and longer the delay between the letters and the cue, the more and more information degrades from memory and the worse and worse they do. So as we look at this performance over this parameterized cue delay, we can get a sense of how robust these people's memory buffers are. So we did that, and we measured this in all of our people, and then we compared these iconic memory curves between the gamers and the non-gamers, and what we found was that for the gamers, everything was shifted up. So they were better at reporting the letters at all of the different delays. And we didn't find that the curve was shifted over, meaning we didn't find that they had a better retention at longer and longer delays, just that everything was better at all of the delays.
And the differences you found were significant across each of the different variables you were looking at?
When we look at this kind of in our quantitative sense, they were significantly different for the amount of information that's initially available and the amount of information that's available kind of in the more durable working memory buffers. But the decay didn't differ between the two groups, which led us to the conclusion that the duration for which information is retained in memory is the same for the two groups. It's just that the gamers have an overall larger amount of information that gets into the buffers right away.
Did you look at any differences within groups? Did you look at differences in gender or race or any other stratifications?
Yeah, so that's an important question because oftentimes it's difficult to find female gamers, right? So we were interested in making sure this was really a phenomenon related to gaming and not gender. And we did some comparisons, so we could discount that in our sample. We didn't look at other things like gender. Our age was a fairly narrow sample. We were interested in college students between 18 and 22, so we didn't find any effects of age. The other thing we get asked about a lot that we don't yet have a handle on is how much gaming. So in this study, we were really taking people who game a whole lot versus people who game not at all. I mean, we didn't really have a good handle on how much gaming. Do you need 5 hours a week, 10 hours a week, 20 hours a week? So that's still an open question.
Right, because that would obviously be my next question. How many hours do you need to begin to acquire this skill? Since I can't ask you that, let me ask you just the operational question, which is how many hours to you is a lot of gaming?
I'm agnostic on that. I don't play video games. My kids aren't old enough yet to play video games. So we did a kind of post hoc analysis. We do have just a little bit of information on the amount of time. And what we found in that kind of small analysis was that the people who played more than 13 hours a week fell into that same kind of category as the avid video gamers. And they had the same benefit in perception that we got when we compared people who just said they're experts at video games versus people who say they never play video games.
Is there a difference, or did you look at types of games? Is there a difference between Madden and football, or people who play video golf or video soccer, and people who are more into fantasy, war, or other types of games?
Yeah, so we did ask about lots of different genres of games. For this study, we were collapsing over both first-person shooter games and action video games, which is kind of a broad category, which includes other types, third-person shooter games, some of the kind of sports games. So those groups all got lumped in together against the non-gamers in our study. There is other work from other groups which is starting to tease apart different genres of games. So strategy games that differ from action or shooter games. Oftentimes, when you're looking at gaming groups, in order to have a good control, we want the people who are not gamers, we want them doing something meaningfully that is kind of not gaming. In a lot of the studies, that non-gamer group is actually people who play Tetris. I think the idea is that it's the action type of video games that are engendering these types of differences. Tetris is a non-action game. So we have a fairly limited view of this in our study, but this is certainly something that's starting to be unpacked in the field.
Now, one of the similarities between research and video games is that once you complete a study or once you complete a level, there's almost always another one. So what is the next question you want to look into?
There are several interesting questions out there. As I mentioned a moment ago, how much video gaming? So what is the numbers of hours a week, or how recently do you have to have played these games in order to have differences? So that's one question. Another question that we're interested in my lab, because we're actually a cognitive neuroscience lab. We're interested in the brain mechanisms that are underlying cognition. So, of course, in this case, we're interested in what are the differences in brain mechanisms that are underlying these differences in behavior that we're observing. So those are both open questions that we're interested in.
I'm assuming in this experiment, it was a one shot, one exposure to the video game or one exposure to the letter recognition test. Are you going to, or have there been other studies that have taken these subjects and looked at them multiple times to see if there's a learning factor in them?
I guess I would kind of flip the question on its head, which is, as people get more and more experience with video gaming, measuring them over and over again over the course of their learning with video games to see how behavior is changing. Is that kind of what you mean?
I was thinking about like history confounds. You know, if someone's used to doing a lot of video games, or not video games, but if they had multiple exposures to this letter recognition test, how would that impact with their video gaming experience, what their learning would be? Would there be a learning curve associated with that you would expect?
Right. So that's typically taken care of when we make a comparison between groups. So there's certainly the case that there is learning on the task that we are presenting them. So we would expect them to get better from the first time they do the letter recognition task to the second time they do the letter recognition task. That learning could be different between groups. So you could have differences at baseline between, say, gamers and non-gamers. You could also have differences in the slope of the learning between the gamers and the non-gamers. In our study, this was really a one-shot exposure. So they only did the letter recognition test one time. So it's not really an active question in this study, but we do a lot of work with learning and plasticity, and that is something that we're interested in, and it is something that we control for, and we build into our statistical models to account for learning that happens over the course of many exposures to our stimuli.
Would you find this quality, the ability to recognize a stimuli in the field, adaptive? Is this a useful trait for people to develop?
We think so, because visual perception is really at the front end of a lot of cognition. In order to recognize objects or validate information into memory, the first thing you need to do is perceive it. So having better perception, we think, is a benefit that kind of expands on to lots of other cognitive abilities.
How generalizable are these skills to other areas?
Well, we think that they could generalize to a lot of real-world tasks, things like identifying friends from foes. If you were in a military setting and you needed to make decisions based upon just a little bit of visual stimulus, well, being able to perceive that visual stimulus better could have advantages. There may be predispositions that are leading our participants to play video games more or not. If they have better visual perception before they ever start playing video games, maybe that makes them better at playing video games, and that reinforces their desire to play video games. So if we really want to get at that deeper question, we would want to do a kind of different type of study in which we would provide the intervention. We would bring people in, we would randomize which group they were in, and some of them would get training on action video games, and some of them would get a control training, and then we would be in a much better position to say something about the causal nature of the intervention. In this case, we haven't done that, so we always want to be very careful in not overstating the relationship.
And that latter experiment might be very difficult simply because of the history confound. I mean, you'd almost have to get kids who are 4 and 5 and 6 years old and then expose them to video games, which hopefully at that point they haven't had much experience with.
Right. So, I mean, finding people who are non-gamers is a challenge in today's age. The other thing is it's very expensive, because if you're going to bring somebody into the lab and say, hey, sit here, play video games in the lab, you have to pay them for their effort. The very fortunate thing about bringing people in who have already done the training for you is that they've already done it for free. They like playing video games. They play video games at home. They sit there and play many, many hours of video games, and you don't have to pay them to do that. The problem is that you lose some of that good experimental control that you would want in order to make the kind of deep conclusions.
Yeah, at least when I was a kid, you could have just paid me a quarter that could go into the machine. Nowadays,
yeah, it's we pay a little bit more than a quarter. So it certainly adds up over time. But we do have intervention studies. We're actually doing a lot of other types of training studies, not just video game. We actually do a lot of work with sports, with athletics, and visual training tools that get used in athletic contexts. In those cases, we can't outsource it. We have to actually do the training in the lab.
Learning how to view things through the prism more accurately, I'm Andrew Hiller for The Voice of Russia, and we've been speaking with Dr. Greg Applebaum. He's an assistant professor of psychiatry in the Duke School of Medicine. Thank you so much for letting us play with you.
And my pleasure. We always want to caution about the causality side of this, because